So we'll continue now with the second part of the Lewis dot diagram for molecular compounds, where we are dealing with double bonds. And actually, we are looking at H2CO. There is a typo there, so please keep that in mind when we're working with it. So now, carbon being with 4 electrons as a bonding capacity is the highest one, since the hydrogen has 1 and oxygen has 2. Then carbon will be at the center as the central atom, and then we will have oxygen in one side and then 2 hydrogens on the other side of carbon. Now, let's start completing, or let's start first calculating the number of electrons for the total. So 2 hydrogen plus 1 carbon plus 1 oxygen, which means that we'll have 2 times 1 electron plus 1 times 4 electrons in the outer shell plus 1 times 6 electrons in the outer shell. So in total, we'll have 12 electrons to place. Let's start with the carbon, which is 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12, 13, 14. As you see, in total we have 14 electrons, which is way more than what we need to have, because in total we have to have only 12 electrons. So what we will do is we will delete 2 electrons on the oxygen and 2 in carbon, and we'll place them as a double bond here. On this case, by erasing those 4 electrons here, what we have is that hydrogen now is satisfied with 2 because it is an exception. It needs only 2 to be happy with the outer shell. Carbon has 1, 2, 3, 4, 5, 6, 7, 8 electrons, so it's happy as well. Oxygen, on the other hand, has 1, 2, 3, 4, 5, 6, 7, 8, and it is completed with 8 electrons in the outer shell. Okay, so now it's time for you to practice on those 2 questions, and then we will move to the triple bond. The triple bonds are created when 6 electrons are shared between 2 atoms, and every new 2 bonds created, 4 lone pairs will be erased from each involved atom. So 2 in 1 and 2 in 1 lone pairs. So let's see now what is happening with the nitrogen gas. Nitrogen gas, the formula for nitrogen gas is N2. That means that we have 2 atoms of nitrogen that we are dealing with. However, in the each of those atoms has 5 electrons in the outer shell. So the Lewis dot diagram for nitrogen will look like this, and for the other one will be the same thing. So this atom has 1 lone pair. Each of them has a 1 lone pair and 3 bonding electrons. So in total, each of them has 10 total valence electrons. So now let's see if we are connecting them with a single bond. So 10 electrons in total. Okay, so let's start placing the electrons in the outer shell by completing the octet rule. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so that means that we have too many electrons here. Way more than what the electrons are available. We have 10 electrons available. So then what we do is we start erasing 2 electrons, 2 lone pairs, and placing them as a double bond. Let's count now how many electrons do we have in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Therefore, we have, again, way more electrons than what it is available. So then we erase 2 more and we place them as the bonds in between the 2 atoms. So then what is happening here is nitrogen gas is formed with triple bonds. Okay, and then we have 2 electrons in for each of them in the outer shell. So now let's count the number of electrons. Is it 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this way, what we have here is we have created that is known as the triple bond. Okay, so if we are doing them with single bonds, then the number of total electrons will be 11, because what we will have here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. Okay, then what we do is we erase 2, and then we create the double bond. So 1, 2, 3, 4, and then what we have here, 1, 2, 4, 6, 7, 8, 9, 10, 11, 12. With double bonds, we have 12 electrons. And then what do we do now is we erase those 2, and then we create the triple bond. So 1, 2, 3, 4, 5, 6, and then 2 electrons here. So the total number of electrons is 10 electrons. And this is what we do when we create the triple bonds. Again, now it's your time to practice on ammonium, nitrate, phosphate, sulfate, and I will videotape the lesson for the multiple central atoms. Okay, so we'll see now the case when we have multiple central atoms, and in this case, the very first one is when we have H2C2H2 or C2H4, which is known with a different name as ethylene. Now, as you see here, carbon, which is we have 2 molecules of carbon here, and what is happening is that we have 2 central atoms because they have the same bonding capacity. Now let's count the total number of electrons in the formula, or from the formula we gather that we have 2 carbons and 4 hydrogens. So carbon has 4 electrons in the outer shell, and hydrogen has 1 electron in the outer shell. So the total number of electrons, of valence electrons, is 12. Let's start building the Lewis dot diagram. So we'll have 2 carbons. Those are connected together because they should. It is a compound. And then we have 1 hydrogen, 1 hydrogen, 1 hydrogen, 1 hydrogen here. Now let's complete the outer shells, or the rest of the outer shell electrons for each of those central atoms. So we'll have 6 more for this and 6 more for this. Let's count now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14 electrons in total, which means that we have more electrons than what is available. So therefore, what do? Is we erase those 2 lone pairs and we place them as the double bonding in between the 2. Why in between the 2? Because hydrogens are satisfied. Hydrogens just need 2 in order to be happy. And therefore, carbon now, each carbon becomes satisfied because it has 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So the Lewis dot diagram will be carbon, carbon, double bond, and then hydrogen on each of those, and then we will have the bonding for the hydrogen here. The same logic will be followed on this case. So the central atoms will be carbon. I will erase this so that we can have enough space to work. So in the formula, what do we have? We have 2 carbon and 2 hydrogen. The number of valence electron for carbon is 4, and the number of valence electron for hydrogen is 2. So in total, we will have 10 electrons. Okay, so 10 electrons as the total valence electron. Now let's start with drawing the Lewis dot diagram. So we'll have 2 carbons that are connected between each other. And then we will have 1 hydrogen in one side and 1 hydrogen on the other side. So now let's complete the outer shell of each of those central atoms with 8 electrons. So 2, 4, 6, 8, 2, 4, 6, 8. When we do so, then what the total number of electrons is 8, 10, 12, 14. Okay, so therefore, what do we do is we erase 2 lone pairs and put them into double bonding. So now what do we have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, too many in comparison to what available electrons are to place into this compound. So then we erase 2 and then we place them as a triple bond now. So then the Lewis, and then when we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is the correct number of electrons. So now the Lewis dot diagram for acetylene is carbon, carbon, and then we will have a triple bond between the 2 central atoms, and then we'll have hydrogen here and hydrogen here. So now hydrogen is satisfied, carbons are satisfied, and then we are good to go. Let's move now to the next one. So the next one is methanol. However, I will erase this work here so that we can use this space to do the work that is required. As you see here, actually we have only 1 central atom here, but then we have a branch that is going around. So you will see that it looks like we have 1, but actually we will have more than 1. When we draw the Lewis dot diagram, you will see. Allow me to erase the space and then I will come back. So in methanol, what we have is we have 1 carbon and we have 4 hydrogen and we have 1 oxygen. So the total valence electrons will be 1 times 4 electrons for carbon, 4 times 1 electron for hydrogen, and 1 times 6 electrons for oxygen. So in total, we will have 14 electrons. Okay, so carbon has the highest bonding capacity, so we'll start with carbon here, and then we will have 3 hydrogens in the side of carbon, and then we will have an oxygen and an hydrogen on the side. Why? Because this is hydroxide. So even when you see it as 3 hydrogens are on the side, and then hydroxide is on its own. Let's start completing the, even when you see this, you notice that we have like 2 central atoms. So central atoms here will be carbon and oxygen, one for this part here and one for this area here. Let's start completing the central atoms with, first of all, with 2 that they are connected between each other, and then with 8 electrons each of them. Okay, and then 2, 4, 6, 8. Now we see that hydrogens are satisfied with 2 electrons, and then let's count now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Therefore, all of them are happy, and all of them have 8 electrons in the outer shell. So the total number of valence electrons is 14, and the Lewis dot diagram for this will be carbon, oxygen, and then we will have hydrogen, 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 and hydrogen here, and then 2, 8. And this will be the Lewis dot diagram for methanol. Okay. Now let's move to drawing the Lewis dot diagram for polyatomic ions. Keep in mind what polyatomic ions are, the ions that are on the periodic table, and they always, as soon as we mention the word ions, means that we have charge. And what do we have to consider? We will see everything as before, we'll do everything as before, but what do we have to consider is that ions are either positively or negatively charged, and when the ion is positively charged, then the electron is lost. So it's taken away. And when it is negatively charged, the electron is gained. So when we are talking about the electrons are losing or gained, we have to take that into the consideration when we calculate the total number of valence electrons. Okay, so in addition to what we have said, when we are dealing with an ion, we have to use square brackets, and we have to identify the charge of the ion. So let's see now when we have Cn minus. Okay, so Cn minus. When it is minus, it is -1. Okay, and then that means that we have 1 electron extra gained. Okay, so now the total valence electron for carbon is 4, number of atoms is 1, so 1 carbon plus 1 nitrogen, and then we have 1 electron. Okay, so the total valence for nitrogen, being on the 15th place of the periodic table, is 5. Okay, so 5, 1, 5, and now the charge is -1, means that we will add 1. So 1 times 4 electrons plus 1 times 5 electrons plus 1 electron as the result of the charge equals to 10 electrons. So we will add 1, and then the total is 10 electrons. You can use this table, or you can use this work that we have here. If you're used to this work, then use the work. If you like the table, then use the table. So now the central atom is carbon. Okay, and we have nitrogen here. Let's complete the outer shell of the central atom with 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 8. Let's count now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Too many. Okay, so then what do is we get rid of 2 and we replace them with a bond, double bond in between the two elements. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, too many. Let's get rid of 2 and replace them with a triple bond. Now, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is the correct number of electrons that we have in place to put into between carbon and nitrogen. So the Lewis dot diagram for this will be using brackets, and we'll have carbon here, nitrogen here, a triple bond between the two, and then we'll have 2 electrons as lone pairs, and the charge is negative. So for ions, what we will do is we will use square brackets and we will show what is the charge. This concludes the second part of lesson 2. You should complete the assignment here, and there is a typo here. We have to do it like this. Okay, this is part of lesson 3 as well. So you don't know about the Lewis structure yet. The same thing is on this table here. So will be again part of lesson 3, even this column here. So complete those, and that's it.